KCSE 2011. The ages in years of 5 boys and 11 while those of 5 girls are this. A boy and a girl are picked at random and the sum of their ages recorded. Draw a probability space to show all the possible outcomes. So we are going to take this one as the girl, and here we are going to take this one as the boy, or boys, girls. So the boys are of age 7, 8, 9, 10, and 11. And the girls are of age 4, 5, age 6, age 7, and age 8. So we have drawn so we are looking for, find the probability that the sum ni kuongeza of their ages is at least 17. So this plus this is 11, this plus this is 12, this plus this is 13, this plus this is 14, this plus this is 15. We go like that. This plus this is 12, 13, 14, 15. So we go like that. It's as simple as that. 13, 14, 15, 16. Here 14, 15, 16, 15, 16, 17. 15, 16, 17, 18. 17, 18, 19. And we have finished. What was I doing? It is 8 plus 11 is 19. So 8 plus 10 is 18. So we are adding the sum. Unaongeza hii na hii na hii. Hivyo mpaka unamaliza. So now the question is, find the probability that the sum penye tumeongeza hivi of the probability is at least 17 years. At least it means 17 and above. At least. So it is 17 greater or equal to 17. So it is 17 and to upwards. So you count ambazo ni 17 na kwenda juu. So hapo tuko na 1. Tunaanza hapa 17 ni 1, 2, 3, 4, 5, 6. There are only 6, 17 and above. So the probability that it is 17 is 6 over the total. The total zote ni ngapi? The total is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So only 25. So now you write the probability sum is at least 17 years is equal to 6 over 25. And you are done. 2016 was repeated, 2010 or 2010 it was repeated on the exactly that year. A bag contains 2 white balls and 3 black balls. A second bag contains a white and 2 black balls. The balls are identical except for their colors. 2 balls are drawn at random, one after another, from the first bag and placed in the second bag. Calculate the probability that the 2 balls were both white. So we have 2 bags. We are picking a ball from one bag, putting into another bag. So I want you to underline the 2 balls were drawn one after another from the first. From the first bag. And our first bag contains 2 white and 3. So we draw the tree diagram for that. So we have white, we have black. White they were 2, the total is 5, and the black there are 3, and the total is 5. So there were 2 balls which were picked. So this is the first ball and this is the second ball. Now, because remember, once you pick, anachukua kwa the first bag anaweka kwa the second bag, hakuna kureplace. Kwa hivyo akishikua ya kwanza ina reduce ikienda. So here we are going to have 1 over 4. Na akipiki white, this is white, black, white, black. Akipiki white hata piki black, kwa hivyo black itabaki 3 over 4. So here is going to pick black itabaki 2. The total is going to be 4. Hapa hata pick hiyo, itabaki 2/4. So the question is, calculate the probability that the 2 balls were both white. So white, 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 white. We have white, black. We have black, white, and black, black. So we want white, white. White, white is 2/5 times 1/4. And this one is 1/10. That is the probability. So probability white, white equal 1/10. To 9, on a certain day, the probability that it rains is 1/7. When it rains, the probability that Omondi carries an umbrella is 2/5. When it does not rain, the probability that Omondi carries an umbrella is 1/6. Find the probability that Omondi carries an umbrella that day. On a certain day, the probability that it rains is 1/7. When it rains, the probability that Omondi carries an umbrella is 2/5. When it does not rain, the probability that Omondi carries an umbrella is 1/6. Find the probability that Omondi carries an umbrella that day. So let us draw a tree diagram. So R stands for rain, and R this does not rain. So the probability that it rains is 1/7. So what is the probability that it will not rain? It is the remaining, which is 6/7. So when it rains, kwa hivyo it is raining now, the probability that Omondi carries an umbrella. So if it rains, the probability that Omondi will carry, so I will use C for carry, and C, this one does not carry. So the probability that Omondi carries an umbrella is 2/5. So the probability that Omondi will not carry an umbrella is 3/5. 3/5, right? Now, when it does not rain, the probability that Omondi carries an umbrella is 1/6. So carry does not carry. So the probability when it doesn't rain, the probability that Omondi will carry an umbrella is 1/6. So the probability that he will not carry, the probability carries is this. The probability that does not carry is 5/6. 5/6. So the question is, find the probability that Omondi carries the umbrella. So we will have R, rain, and on a paper. Rain does not carry, does not rain, and carries, does not rain, does not carry. So we want this and this because carried the umbrella. So this is the probability RC or does not carry C. And that one is simply 1/7 times 2/5 plus 6/7 times 1/6. And this one will give us 1/5. That is the probability that does not, it carries an umbrella. A student at a certain college has 60% chance of passing an examination at the first attempt. Each time a student fails and repeats the examination, his chances of passing are increased by 15%. Calculate the probability that a student in the college passes an examination at the second or at the third attempt. So, first attempt, pass, anapata 60%. That would mean a student has 60% for passing for the first attempt. So the first attempt is 60. Each time a student fails and repeats examination, his chance of passing are increased by 15. So we are going to increase this one by 15. So second attempt, the pass itakuwa 60 times 115 over 100. Na hiyo inakuwa 69%. What about the third attempt? Third attempt, calculate the probability that the student in the college. So third attempt itakuwa ni ku increase this one by 15%. So 69 times 115 over 100. This one will give us 73.35%. Now, the question is, find the probability, calculate the probability that the student in the college passes an examination at the second or at the third attempt. So, wacha tuangalie hii mwanafunzi hapa, kuna pass, kuna fail. So, ili ya pass ni 60%. 60% is 0.6. Now divide by 100, 0.6, ama itakuwa 6 over 10, whichever unataka. Tutumie 0 decimals. So akifail, kama pass ni 0.6, so fail itakuwa 0.4. Kwa lazima ijae 1, so fail. Kwa hivyo amepass hapa. So akifail anaenda second attempt. Sawa? Second attempt kuna kupass, kuna kufail again. Sawa? Hapa second attempt tumepata ni 69, that is 0.69. Tukitumia decimals, 69 over 100 is 0.69. Kwa hivyo the fail itakuwa 0.31. Na amefail tena, ataendelea pass, fail. Sawa? Hapa the third attempt tumepata kupass ni 73.35, which is 0 point that. But this one, so the other fail itakuwa 0.2065. So the question is, calculate the probability that the students in the college passes an examination at the second or at the third attempt. So for this student to fail the first attempt, the second attempt atapass. So we are going to find the probability fail and then pass, fail then pass, or the third attempt will fail and then the third will pass. So the third attempt itakuwa fail, pass. So fail, pass. So that's so we are going to get this one is 0.4 times pass, which is 0.69, or this we add fail, pass, that is 0.04 times 0.31 times 0.735. Yes. So this one will give us a total of 0.374394. So the probability of passing the second attempt or the third attempt is that. (27) 2007. 2 bags A and B contain identical balls except for the colors. Bag A contains 4 red balls and 2 yellow balls. Bag B contains 2 red balls and 3 yellow balls. If a ball is drawn at random from each bag, find the probability that both balls are of the same color. So hapa kuna kitu kimoja nataka nikufahamishe kwamba hatujaambiwa kwamba a bag was selected at random. Kwa hivyo hapa hakuna kutumia a have. a bag was not chosen. Huyu mwitu anaweza kuwa na bags mbili. Hizi ni bag mbili. Aingize mkono wa kushoto hapa ndani na mkono wa kulia hapa achukue. Kwa hivyo hakuchagua. So here there is nothing saying that I have bag A, I have. Picking I have, if you are told a bag is chosen at random, is selected at random, that's when we use I have. Nadhani umeelewa the difference. So now we have this one, we can do them separately. Bag A tunajua the total 4, so it is 6. Bag B tunajua 2 red, 3 yellow. We can do it separately, but I prefer to tumie the tree diagram. So ni vizuri kutumia tree diagram. Nataka uzoee kutumia tree diagram. Kwa hivyo hii ni bag A. Bag A red. Bag A yellow. Bag A red, they were 4 and the total is 6. Yellow, they were 2 and the total is 6. And then now we can go to the next bag, which is bag B red, bag B yellow. So we can also fit this one as bag B red, bag B yellow. So bag B, we had how many? We had 2 red, 2 over 5. Yellow, they were 3 over 5. We repeat the same here, 2 over 5, 3 over 5, that is yellow. Now, what is the probability of choosing probability both balls are of the same color? So we can have A red, B red. So we have red here. We can have same color, so we will have yellow, A yellow, B yellow. So that's what we want. That's what we want. So we will have probability either red or yellow. The probability red or yellow, and that is 4 over 6 times 2 over 5, or we add yellow, that is 2 over 6 times 3 over 5. And this one gives us 7 over 15, and you are done. Number B. If 2 balls are drawn at random from each ball, one at a time, without replacement, find the probability that the 2 balls drawn from bag A or bag B are red, or the 4 balls drawn are of red. Kwa hivyo hapa tunaenda individual bag kwa sababu it is drawn without replacement. So we can start, but now BP sasa tunachora tree diagram for bag A only. We have red, we have yellow, and then 2 balls are chosen. Hii ya kwanza ni first ball, this ya pili ni second ball. Kwa hivyo hapa tutakuwa na red na yellow, red na yellow. Kwa hivyo tunajua ya kwanza ilikuwa na 4 balls over 6, ilikuwa na 2 over 6. Kwa hivyo akichagua the second ball na arudishi ndani, itakuwa inapungua by 1. So they were 4, tuchukue pick 1, itabaki 3. Toto itabaki ngapi? 5. Because it is without replacement, haturudishi tena ndani. Ukishachagua ni hivyo. And if I pick red, I won't pick yellow at the same time. So yellow will remain to be 2, but the total will be over 5. So now I'm going to pick yellow. So itabaki 1 over 5. And if I pick yellow, I won't pick red. So red will remain to be 4. So it is 4 over 5. Now for this one we will have red, yellow. We go to bag, this is bag A. I can have bag B here. My bag B here. We have red, we have yellow. The first ball, the second ball. ya tulikuwa na 2/5, 3/5. Here what, and then ukichukua red in bag B, if you pick red, it will remain 1/4. Ukichukua red hautachukua yellow at the same time, so itabaki 3/4. If you pick yellow, itapungua by 1, ikwe 2/4. Hii itabaki 2/4. Sawa? Now that's the bag B. Now what is the probability? The two balls drawn from bag A or bag B are red. They are red. So the probability, the question asks, the two balls drawn from bag A or B are red. That simply means probability two balls are red is equal to the probability from A, both are red, probability from B, both are red. B both red, A both red. So here, A, probability red, we have red, or that is for A. For B, probability red in B. So red, here for A it will be 4/6 times 3/5. Or we add probability in here, bag B. Bag B, red is 2/5 times 1/4. And this one will give us a total of 1.5. The probability is 1/2. Finally, the last question. The probability that all the 4 balls drawn are red, or all of them that were picked were red. So that's what we want to do, is to calculate the probability all the 4 are red. This is the same as probability from A, both are red, and from B, both are red. So when we use and, we multiply. When we use or, we add. That's why we added here. But in this case, we are going to use the same 4/6 times 3/5 times this one, because it is and the answer is 1/25. Two integers x and y are selected at random from the integers 1 to 8. If the same integer may be selected twice, find the probability that x minus y modulus equal to 2. Modulus, it means you consider negative. A negative number, modulus is always positive. So -2 modulus is 2. And then we find x minus 2 is 5 or more. X minus this is modulus. So what we want first to get the probability space for that. So I will draw it very fast. So I have drawn the sketch of the probability space. So we are told that x minus, so if this one I give it, this one is x and this is y. So x minus, so it is this minus this x. So 1 minus 1 is 0. 1 minus 2 is -2. 1 minus this is negative 1. 1 minus 3 is -2. 1 minus 4 is -3. So inaenda -4, -5, -6, -7. Inaenda hivyo. So ukishapata hii ya kwanza, the others you will just go. So if it is 1, the next one is 1, 2, 3, 4, 5, 6, 7. So ukishafanya sasa inaenda haraka. After negative itakuwa 0. 1, 2, 3, 4, 5, 6. Yani number mbele ya negative, mbele ya so you go like that. The number in front of -2 is -1. Then 0. And then 1, 2, 3, 4, 5. So we are not guessing, it's like 8 minus 3, the answer is 5. 7 minus 3, the answer is 4. So badala ya kushinda ukifanya hivyo, ukishaona the trend, you just fail. So this one is -2, -1 is 0. 1, 2, 3, 4. So these outcomes are obtained by x minus y. X minus y. 4 minus 2 is 1. 5 minus 4 is 1, like that. So now we want to calculate the probability x minus y is equal to 2. So that one, so Roman 1, we consider all -2 and 2. So because -2, modulus is 2. The modulus of a negative number is a positive number. That's more hivyo. So now we are looking for all numbers that are -2 or 2. So you just count manually. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are only 12, as you can see. So we will have, so the probability x minus y modulus equal to 2 is equal to 12 over the total. The total is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 8, 64. And this one is the same as, you simplify 3 over 16. So that is simply what they wanted you to do. Roman 2, the modulus is 5 or more. So we want to check that it is -5 or 5 or more. So it can be 6, 7, 8. Yeah, or more. So that one, we want the probability x minus y modulus is equal to 5 or more. That simply means 5 greater than 5, at least. It means at least 5. It means at least 5. At least 5. So we will find -5 and 5. Kwa nini? Kwa sababu the modulus of x is either -5 or 5. So tunaangalia yenye iko -5 kwenda juu na 5. So let us count all of those that are 5, 6, 7, 8. You count all of them. So let us count. 1, 2, 3, 4, 5, 6. Hapa hakuna. 7, 8, 9, 10, 11, 12. So umeona ni 12. Zote zenye ziko more than 5, whether ni negative or positive, they are 12. So the probability this is equal to 12 over 64, which is the same as also 3 over 16. Next number is Roman 3. X is greater than y. So the probability x is greater than y. Where is x greater than y? If x is greater than y, we consider all the positive values that are inside this probability space, all positive numbers from 1 to 8. So we count all of them. So we start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 28, 24, 25, 26, 27, 28. So there are only 28. So x is greater than y. It is all the positive numbers, and that there are 28 out of 64. And this one is 7 over 16. Two teachers are chosen randomly from staff consisting 3 women, 2 men to attend HIV/AIDS seminar. Calculate the probability that the 2 teachers chosen are of the same sex, of opposite sex. Remember, when a person is a teacher, one teacher is chosen, the number reduces. Don't wait to be told with replacement, without replacement. So we have, this is the teacher men. You can start with women and then men. But the two teachers, this is the one teacher. This peak is one teacher. So the second peak, the second teacher is here. Woman, man. This is the second teacher. Woman, man. Two teachers we have said. Women, they were 3 over 5 because the total is 5. So men are 2 over 5. So when a woman is chosen here, the number reduces to 2 over 4. When a woman is chosen, a man cannot be chosen at the same time, so man will remain 2 over 4. When a man is chosen, the number reduces from 2 to 1 over 4. The total reduces to 4. And when a man is chosen, there's no way a woman will be chosen at the same time, so the woman will remain to be 3 over 4. Now we want the probability A that it is of the same sex. Same sex, it means woman, woman, or man, man. That's what we, so we want the probability woman, woman, or probability man, man. That's what we want. So woman, woman will be 3 over 5 times 2 over 4, or we add that of man, man. It is 2 over 5 times 1 over 4. And this plus this will give us 2 over 5. Part B, of opposite sex. Opposite sex, it is woman, man, or man, woman. So this is a probability woman, man, or man, woman. That is the opposite sex. And that one would be equal to 3 over 5 times 2 over 4, or man, woman, 2 over 5 times 3 over 4. 3 over 4. And this one will give us 3 over 5. There are 3 cars A, B, and C in a race. A is twice likely to win as B, while B is twice as likely to win as C. Find the probability that A wins the race. B, either B or C wins the race. So we can start by saying that let the probability of C win be equal to X. So if C, the probability of C is X, then the probability of B win will be twice, because we have told that B is twice likely to win as C. Very good. So the probability that A win is going to be 4x, because A is twice as likely to win as B, and we have B. So B twice, that is 2x times 2 is 4x, right? So find the probability that the probability that A or B or C wins will be equal to X plus 2x plus 4x, and that one will give us 7x. But if all of them win, then the total probability is going to be 1. We know that the range starts at 0 to 1, so the probability is 1. So it means that 7x is equal to 1. All of them would win. So we want the value of x divided by 7 divided by 7. So x is equal to 1 over 7. So x is 1 over 7. So the first question is the probability that A wins. So A, probability A wins will be, we know A is 4x, so it is going to be 4 times 1 over 7, and that is 4 over 7. That is the probability A wins. Part B, either B or C wins. Either B or C wins. So that is the probability B or C wins. So that is the probability B. We have B win, that is 2x, that is 2 times 1 over 7, plus probability C wins, which is equal to C is x, that is 1 over 7, plus 1 over 7. So the total will be 2 over 7 plus 1 over 7. And the answer is going to be 3 over 7. So the probability B or C win is 3 over 7. An unbiased coin with two faces, head, that is the H, and tail T, is tossed 3 times. List all the possible outcomes. Hence, determine the probability of getting at least 2 heads, only one tail. So here, there we need to draw the probability, the tree diagram that will help us. So this is the first toss, which will have tail and then head. Whichever way you will start, it is head or tail, but it is important we start with the head and then tail. But for it to come here, we must have it is a half. For a head to come, it should be a half. That one you should know. So that is the first toss, the second toss, and this is the second toss. We will have the head, the tail, head, tail. The third toss will be like this. This is the third toss. We will have the head, tail, head, tail, head, tail, head, tail. So we will have head, 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 head. We will have head, head, tail, head, head, tail. We will have head, tail, head, head, tail, head, head, tail, tail, head, tail, tail. We will now come here, tail, head, head, tail, head, head, tail, head, tail, tail, head, tail, 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 head, tail, tail, head, and then tail, 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 tail. 1, 2, 3, 4, 5, 6, 7, 8. So baada ya kuchora hiyo, sasa tunaweza we can answer at least 2 heads. So we must have at least 2 heads. So it is 2 heads and above. So this one can be 1. 2 heads are here. We have 2 heads here. Here there is no 2 head. There is 2 head here. So it is the probability this or this or this or this. Right? So we are going to add those probability. But remember, this is a half, or everywhere is a half. A half. Everywhere is a half. A half everywhere. So the probability head, 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 or head, head, tail, or head, tail, head, or tail, tail, head, head. So those are what we want. So that one is going to be a half times a half times a half. How many are they? 1, 2, 3, 4, and then times 4. The answer is going to be a half. Only one tail. So we want where we have only one tail. So where we have only one tail, this is 2 tails, 2 tails, 2 tails, only one tail is here and only one tail is here. So that is the probability. Head, tail, head, or head, tail, head. And that one will give us 1/2 times 1/2 times 1/2. Where do we have, where else do we have one tail? Oh yeah, there is this one, head, tail. There are 3 times 3. This one will give us 3/8. There is, or this one, kwa nimesahau HT. Only one tail. Mahali T peke yake iko moja, that's what the probability we want. A contractor applies for 2 contracts. Contract A is building a school workshop and B, building a school library, right? The probability of getting A is 0.6. So the probability of not getting A is 0.4. The probability of getting contract B depends on whether or not A is obtained. Yes, and is this one. If A is obtained and only if A is obtained, and only 0.4 if A is not obtained. What is the probability of getting at least one contract? So we draw a tree diagram. So there is getting A and not getting contract A. So the probability of getting contract A is 0.6. Then obviously the probability of not getting A is 0.4. So the probability of getting B depends whether A was obtained. So now A has been obtained, so let us go there. We are going to B, A, and then we are going to, does not obtain B. If it does not get obtain this one, you will get B, B like that. So we go back. The probability of getting A is 0.6. The probability of getting B depends on whether whether or not A is obtained, and is 0.7. So if A is obtained, for this to get the B is going to be 0.7. So not getting B is 0.3. So 0.4, and then depends on whether if A is obtained. So if A is obtained, we have, and only 0.4 if A is not obtained. So for if A is not obtained, to get B is going to be 0.4. So 0.4 here remains 0.6 to be full. Yes. Now the question is, what is the probability of getting at least one contract? At least. So kuna A, B, kuna A not getting this, kuna A not, B, kuna A, B not. So here hajapata yeyote. Lakini here there is one contract, and there is two contract here, at least one. So this one is in. So we want a probability this. So now we want a probability AB or AB prime or A prime B. That's the probability we want. And this one is going to be AB is 0.6 times 0.7 plus 0.6 times 0.3 plus 0.4 times 0.4. This one is going to give us 0.76.